what happens in class diagram? Here we give an overview of the whole system. In our whole system, what happens? We have different objects we will have. So for those objects we should have certain classes, right? So we will represent the whole system in terms of classes and how these classes are going to interact with each other. That's it. Simple. Okay. So this class diagram will be considered as a static. Static means it will remain as it is. It shows just the static behavior that this is something. Okay. We will also see dynamic diagrams where we will see how to react on a certain event. Okay. We will see activity diagrams or sequence diagrams. They will be considered as dynamic diagrams. This is a class diagram which remains as it is, okay, which doesn't show anything related to any event. It just shows the overall architecture of your system. So here you can show that these classes do interact with each other, okay, and when they interact with each other. You can show the attributes and operations of each class. So this is a good way to describe the overall architecture of your system. Now, see few things that we should understand. What are the perspectives, right? So we take it like there can be three different perspectives. One is we want to lay out our conceptual perspective, which will be dependent on the software. It may also be, it should be independent of software, and it should be independent of the language. You will have a class, whatever the attributes and functions will be. It should not be written in any particular language. Okay. It should be, what is the specification perspective? It focuses on the interfaces of the software. Implementation perspective says focus on the implementation of the software. Let it be. So classes, we have already talked about it. What is a class? It represents a concept, represents the blueprint or template of the particular objects. It acts as a data type for the object. Now here we have three things. One is name, attribute, and operation. So here you have to understand that when you represent a class in a class diagram, what happens? You represent it like this. Let me remind you, you are representing a class, and when you represent a class, you represent it like this. Like this means one rectangle having three parts. In the first part, you write the name. In the middle part, you write the attributes. There can be multiple attributes. 1, 2, 3, 4. Multiple attributes can be there. And then the operations, whatever the operations are for this class. So in this way you represent one class. Not only this, these attributes may have data types. Okay, data types can be int, float, whatever, whatnot, all those data types. Here you can see these methods that you are defining here. These methods or operations, what you would call, they will have their signature. Signature means what will be the input parameters, their types, or what will be the type of output. Okay, so this will be considered as signature. So you can have this signature in this code, in this class. So let me repeat, in class diagram you have a class. So this class is something like a rectangle where you have three portions. One is class name, attributes, and the operations. Okay. Now let me tell you one more thing, that sometimes I have seen some people drawing ER diagram as class diagram. Okay. The thing that what happens in ER diagram, you have entity name and their attributes. So rather than showing the attributes in separate ovals, what you can do, keep the attributes here in this particular format. But let me repeat, it will be class diagram, it will not remain a ER diagram. Okay, so you have to keep this thing in mind when you are asked to draw ER diagram. You should draw ER diagram only, not the class diagram. So yeah.
So what is signature?
Signature is I should say the method name along with its data types for input parameter as well as output. Did you understand? Should I repeat?
Is it different from operation?
No. See, this is the get price. Get price is the name of the operation. Here also get price is the name of operation. Signature says that what will be the data type of something which goes in output of this function, this method, and what will be the input parameter. Okay, so this is the signature of your operation or method get price. Did you understand? Should I repeat?
No, sir, no.
Okay, so what we talked about is, this is the name of the operation. If only name is given, it is like this. With signature means it also defines what are the type of data type of input and output. Okay.
Excuse me, sir.
Yes.
Sir, if there are functions like we have multiple functions with same name but different number of parameters, right? So how do we have to write each and every function?
Yes, you will have to write each and every function.
Okay.
So that particular thing you have I am just reminding it that you have the same name of the function but different signature, you call it. Okay. So this phenomenon of having same name of function with different signature, what do we call this in OOPS concept?
Function overloading.
Yes, it is called overloading. Okay. So let us talk about instance. What is this instance?
It is the object created using class.
So this is the object created using the class. The type of this object is the class that we have made. Here you can see the name of the class was tariff schedule. Okay, so here you can see this is tariff 1974. This is your instance or an object which is of type tariff schedule, and these are its values of the attributes. Okay, so when you try to represent an instance of the class, you represent it like this, and attributes are having their values. Okay, so in a class notation, how do you make a class in a class diagram? You have the class name along with attributes and the methods. More than that, you can specify the attributes which can be in private mode or public mode or protected mode or even static. So for representing this thing, you can use these symbols: minus, plus, hash and underlined. Okay, so if you want to have an attribute name, you are defining its type. If you want to have attribute name as a private attribute, you will have minus sign in front of it. Similarly, plus for public, hash for protected, and it is underlined for static. Now here you can also understand these are public or protected, whatever methods are there. Other than that, this is the name of your class. This name can be italic if at all it is an abstract class. Do you understand what is an abstract class? Some of you.
Abstract class is used for defining other classes.
Okay, but
It is the way.
when do you?
We cannot make the object of abstract classes.
Why?
So abstract classes, maybe we just use as a super class only.
Why? Why cannot we make an object of abstract class?
So we use that class as a super class for other classes. Means we define other classes using this class. This is we can say that this is the main data structure type thing for other classes
Okay.
which implement this class. Then they make
This
make
is true.
objects of.
This is true that this can be used later on and can be derived by other classes. However, I want to understand, if I want to make an object of this abstract class, why is it not allowed?
Sir, because in abstract class we don't define the behavior, the complete behavior of that
Yeah.
object. We just define the behavior, but we don't define what will be the exact functionality.
Yeah.
So we define that exact functionality in the derived.
Okay. Yeah, let me repeat what he has said. He has talked about the operations here. We have a method name set name. Okay. So just giving the name of the method set name is not enough. Along with the name of the method, we should also define it. Defining it means writing the code inside this function, which will let the object use it. If at all this function was not defined, in that case this class needs to be defined as abstract. Okay, so that the other class who will derive this class can give the definition for this particular method. So since some of the operations, it is not required that all the methods should not be defined. If some of the method, even at least one method was abstract, was not defined, in that case the class has to be made as abstract. So if you have certain such type of classes, then you can represent it in italic. The name should be in italic. So other than that, two classes are there. These two classes, how they communicate with each other, how they collaborate with each other, you can show some relation between them. Okay, so these relation can be of these four different types: association, aggregation, composition and inheritance. Okay, association means what happens? Instance of two classes, they can communicate with each other. Okay, the thing is that these two classes should be aware of each other. That's it. This association will be indicated with a straight line. there is something called aggregation. Aggregation means it is also an association where one class belongs to a collection, like instructor part of faculty. Okay, so when you have to show a relation something like part of, like leg is a part of chair, in such cases you use aggregation representation. So if you want to show some aggregation that this class belongs to that particular class, in that case you can show indicate by empty diamond on the side of collection. Composition, this is a strong form of aggregation where you can understand that the components cannot exist without the aggregation. Okay, means without, if you do not take it together, they do not exist. Okay, indicated by a solid diamond in the side of collection. Inheritance is what? When there is a superclass and there is a subclass, base class and subclass, they are that kind of relationship. So bird is a part of mammal. This can be indicated by a triangle pointing to the superclass. Let me show you this thing here. This is simple binary association that A and B, they both know each other and they are using each other's service. Like here you have created an object of type B and you are using the operations, the methods of B here, and it is using the methods of A. So such kind of association can be represented by a single line between the classes. Unary Association, which says that A is using B, however B is not using A. In that case, such kind of arrow towards B can be shown. Aggregation. Aggregation is an association with a collection member relationship. So what is happening here? This is a crate, another class module which is being used here in crate. Okay, one thing is that here this module are the member of this crate. Okay, so such thing can be represented as this symbol where you have a hollow diamond on this side, collection side. Okay, we have talked about it, right? Aggregation, it is also same thing, collection member relationship. We have talked about aggregation or what? Yeah. Composition is strong form of aggregation. There what happens? You have a lifetime control. Owner controls the construction, destruction, whatever we have to do with this particular object. So in team you have multiple employees. You can have this employee, and these employees can be created, destructed, whatever needed can be done here. All the operations of this can be used here, no issues. This can be represented as this filled diamond on the collection side. Okay, inheritance, you understand, this is a class of base and derived class, where derived class is B, which inherits A. That means it inherits A with its attributes, and the methods all comes in B. Okay, you would have seen this kind of code somewhere. Class B extends A, such kind of things. Okay, so again I am coming back. Okay, multiplicities are similar to those that you would have seen in ER diagrams. Okay, one to one, one to many, many to many, such kind of things, right? So here also we can represent those things. However, we should represent it like this. We have the starting and the dots, which represents between 0 to 1, 0 to any number or just any number, 1 exactly 1, or here 1 to any number, that means at least 1. 0 to 1 means either 0 or 1. It can be 0 to 2, 0 to 3, whatever, according to your limit, your things. Okay, the notation can also be n to m, any number to any number, according to your need. Okay, so what are these? In such kind of diagram, you can see, you can represent it something like, on this side, one instance of customer may have 0 or more, 0 or any number of orders. One order can have at least one payment or more than one payments as well. Okay, these payments can be of any type. It can be credit card, cash, or check, any type of payment it can be. Here orders will have order details. One order will have at least one or more order detail. Order details may have, means one instance of order detail may have only one details of item, even if more order details are there, but the instance of item will remain single. Okay, so such kind of things, if you have, you can use these things to represent your class diagram. Okay, I came back or what? Okay, so okay, here we are saying that we can give some details as well. Okay, if there is a relationship on these individual side, we can give some detail. Here you are writing team as a group. On employee side, you are writing individual, right? So you are giving some kind of detail. Okay, no problem. Static versus dynamic designs. So in a static diagrams, what happens? They just describes the code structure or the relationships, nothing much. Your class diagram or object at a particular design type, they does not change at one time, right? So they are static design. However, dynamic design shows the communication between objects, like the objects are there, how they will communicate, what will be their reaction on a particular event. Okay, so such diagrams will be considered as dynamic diagrams. Object diagrams are also static diagrams. What happens in object diagrams? At a particular time instance, there are certain objects. How they are related, it can be shown here in object diagram. Okay. So at a point of time, we may have a certain selected focus. What is the focus? It can be interaction among the objects. It will be a sequence diagram. Message passing, how the message is being passed, it will be collaboration diagram. What are the operations to be done or can be done? It is our deployment diagram. So these are the few things in object diagram. We will see these diagrams later on. It's okay, we know that how object is written. It gives the ID name for the object and the class name and their attribute with the values. We will see some more things in class diagram later.